Evaluate 0 over 21 and 8 over 0. The first one, 0 over 21, if you have 0 and we divide it into 21, we would get 0. Or if you have 0 divided into anything, like half of 0 would be nothing. If you take 0 and divide it into 25, it still would be 0. So the first one would be equal to 0. And 8 over 0, we are dividing 0 into 8. This is known as undefined. When we divide 0 into any number, we have undefined. Now, if we forget which is which, we can actually divide these and make a long division. If I divide 21 into 0, what time 21 would be equal to 0? So obviously is 0. 0 times anything is 0, so the remainder would be 0. However, if I divide 0 into any number like 8, when I ask myself, what time 0 give me 8? Obviously, I cannot find any number multiplied with 0 to get any number but 0. If I pick 0 here, 0 times 0 would be 0. It's not equal to 8. If I pick any number, when I multiply it by 0, I would get 0, so I would never get 8. So that's why we would say undefined here. We cannot divide 0 into any number. Remember, the answer would be undefined, not 0 or impossible or any other answer. So when you divide any number into 0, the answer would be 0. When you divide 0 into any other number, then we get undefined. Give an example of commutative property for addition and multiplication of real number. The word commute means to go back and forth. Like people commute to work. When you go from your home to work and take the same path from work to home, you travel the same distance. The commutative property says when two numbers are added or multiplied in any order, the result is the same. So for addition, A plus B is the same as B plus A. For multiplication, A times B would be equal to B times A. Example of commutative property for addition would be if I have 2 plus 3 is the same as 3 plus 2. That would be a simple example. Example for multiplication, we can say 3 times 7 is the same as 7 times 3. This would be example for commutative property of addition and multiplication. Give an example of associative property for addition and multiplication of real numbers. The associative properties says that when you add or multiply three numbers, you can group the first two together or the last two together and get the same result. So for addition, if I have A plus B plus C, I can group A, B first and add these two together and then add the result to the last term, or group the last two terms together and add the result to the first term. And for multiplication, we can do exactly the same and we get the same result. Example would be if I have 2 plus 3 plus 4 would be the same as adding 3 plus 4 first and then add the result to 2. And you would get the same exact results. For multiplication, if I have 3 times 5 times 6, that would be the same as multiplying 5 and 6 first and multiplying the result by 3. That would be an example of associative property for addition and multiplication. Give an example of inverse property of addition and multiplication of real number. Minus A is the inverse for addition or opposite of A, and 1 over A would be the inverse for multiplication or reciprocal of non-zero number A. We say non-zero number because A cannot be equal to 0. Then 1 over A cannot be equal to 0 because we would get undefined. The sum of the numbers, and if you have A and negative A, would be equal to 0. The product of the non-zero numbers A and 1 over A is 1. So when I have a number A and its opposite number is minus A, when I add these two numbers, the result will be equal to 0. Or if I have an A and I take the reciprocal of that number, 1 over A, when I multiply these two numbers together, the result would be equal to 1. Example of this would be if I have 2 and its opposite is minus 2 or negative 2, that would be equal to 0. Or if I have a number 2/3, its reciprocal is 3/2, the result would be equal to 1. Simplify. 4 minus 3 minus 8 plus absolute value of negative 2. We follow the order of operation. From left to right, we look for parentheses. We don't have any operation inside the parentheses here. We look for exponents. We don't have any exponents. We can evaluate the absolute value. Absolute value of negative 2 is equal to positive 2. When we talk about the absolute value, we are looking at how far the number inside the absolute value is away from 0 in the number line. The number -2 is 2 units to the left of 0. It's 2 units away from 0. Therefore, absolute value of -2 is equal to 2. So absolute value of a number refers to a distance of the number inside the absolute value to 0, since the distance is always a positive number. So absolute value of -2 would be equal to +2. For the same reason, absolute value of +2 would be equal to 2 also, because it's also number 2 on the right side of the 0. It's exactly 2 units away from 0. So the results of absolute value of -2 and +2 would be positive number, because it's referred to a distance of the number to 0, which is 2 units. So in this case, we have 4 minus 3 minus -8 plus, so absolute value of -2 would be equal to 2. So we go from left to right. We have 4 minus 3 would be equal to 1. We're following the order of operation. From left to right, when we subtract integers, we can change subtraction to addition and change the second number to its opposite number, which would be +8. So we have 1 plus 8 is equal to 9. 9 plus 2 would be equal to 11. Simplify. -5 to the power of 2 minus -5 to the power of 2. Now the difference between these two is when you have -5 square, or if you have -5 square and the 5 is inside the parentheses. The first one, the base is 5, so we only multiply 5 by itself 2 times. So the result would be -25. The second one, the base is -5, so we multiply -5 or -5 by itself 2 times, and we would get +25. So if you want to include the negative with the exponents, you have to surround it by the parentheses. So in this case, -5 squared results into -25, and -5 to the power of 2 would be +25. So we have -25 minus +25. So the result would be equal to -15. Simplify. We follow the order of operation. We have 21 minus 2 times, we have some operation inside the parenthesis which has the highest priority. We have to do this one first. And in the denominator, we have to follow the order of operation also, and follow the operation inside the brackets first. So we have 3 minus 2 squared would be equal to 4. So we have 3 minus 4 times 5. And when we follow the order of operation inside the parentheses at the top of the fraction, we have to do the multiplication first. So this would be equal to 3 minus 20. So at the top of the fraction, I would have 21 minus 2 times 3 minus 20. And at the bottom of the fraction, I would have negative 1 squared would be positive 1. That would be just 1. Plus 4 squared would be 16. 4 times 4 is 16 minus 6. So from left to right, I have 1 plus 16, which would be 17, minus 6, which is equal to 11. So we'd have 6 plus 11 for the denominator. So here we have 3 minus 17, which is equal to 3 minus 20, which is equal to negative 17. So we have to go from left to right and do the multiplication first. So we have 2 times negative 17, which results into negative 34. So far we have 21 minus negative 34 over 6 plus 11, which is equal to 17. So here we are subtracting integers. We keep the same number as is. We change the subtraction to addition, and we write the second number as its opposite. Opposite of negative 34 would be plus 34 over 17. So we have 21 plus 34 would be 55 over 17. I want to make sure this is simplified, which it is, and that's the result. Simplify. 4 over 13 divided by 1 over 26. When we divide fraction, we keep the first fraction as is. We change the division to multiplication, and we write the second fraction as its reciprocal, which is 26 over 1. So in general, if I have A over B divided by C over D, that's the same as A over B times D over C, which is reciprocal of C over D. And then we simplify and reduce this. We have 13 and 26. If I divide this into 13, I would get 2. If I divide this into 13, I would get 1. So I would have 4 times 2, which is equal to 8. 8 over 1, or just 8. Convert the decimal to fraction. 0.22. 0.22 is the same as 22 over. Now, the first 2 is in 10th position. The second 2 is in the 100th position. So this must be over 100. We have 22 over 100. We have to reduce this. Divide top and bottom of the fraction into 2. We would get 11 over 50. Convert the decimal to fraction. 1.38. 3 is in the 10th position and 8 is in the 100th position. So we can write this as 138 over 100. When we reduce this, we divide both of them into 2, we get 69 over 50. Translate 3 more than 5 times the square of a number. Let the number be equal a variable. We can't call it anything we want. Let's call it n. So to translate this, we have 3 more than 5 times the square of the number. So 3 more than would be 3 plus 5 times square of a number. If the number is n, the square of that would be n square. So we translate it like that. 3 more than 5 times the square of the number. The number is n, the square of the number would be n square. Translate 5 times the sum of a number and 2. Let the number be equal to a variable like n. Then 5 times the sum of a number and 2. So we have 5 times the sum of the number and 2 would be n plus 2. So the sum of the number and 2 would be n plus 2. 5 times that would be 5 times that number, which is 5 times n plus 2. Evaluate a plus 2b over 3a minus 4b. When a is equal to 2 and b is equal to minus 3. We substitute for every a in this expression 2. And we substitute for each b, its corresponding value, in this case is minus 3. You notice I use parentheses for each variable. Here I have 3 times a is equal to 2, minus 4 times b is equal to minus 3. I just have to follow the order of operation. Here I have the top of the fraction, 2 times minus 3 would be equal to minus 6. So I have 2 minus 6 at the top. And here I have 3 times 2, which is equal to 6. Here I have 4 times negative 13. 4 times negative 3, which is equal to negative 12. So here I have 6 minus negative 12 is the same as 6 plus 12. We change the subtraction to addition, and we write the opposite of negative 12, which is positive 12. So at the top of the fraction, I get minus 4. And at the bottom of the fraction, I would get 18. I have to reduce this, divide top and bottom of the fraction by 2. I get negative 2 over 9. Solve for u. We have t is equal to 1/2 u minus 3. So we have to isolate u. So when you have t minus 1/2 u minus 3, I can add 3 to both sides of the equation. I would get t plus 3 on the left hand side, and I get 1/2 u on the right hand side. To isolate u, I need to eliminate 1/2. To do that, I can multiply 1/2 by its reciprocal, which is equal to 2 over 1. So if I multiply both sides of the equation by 2 over 1, I would get 2 times t plus 3 on the left hand side, and on the right hand side I would get 2 over 1 times 1/2 times u, and as you see, 2 over 1 times 1/2 would be equal to 1, so I would get 2 times t plus 3 on the left hand side, which is equal to 1 times u, or u. And I isolated the u, so u is equal to 2 times t plus 3. Well, I can write u is equal to, I can distribute this, I get 2t plus 6. Solve for y. We have 2x plus 3y is equal to 6. To solve for y, I have to isolate y by adding, in this case we have 2x on the left hand side, which I need to eliminate. If I add minus 2x to both sides of the equation, or subtract 2x from both sides of the equation, I would have 3y the left hand side, and the right hand side I get 6 minus 2x. I'm isolating y. To have y all by itself, I need to eliminate 3. To do that, I multiply both sides of the equation by reciprocal of 3, which is 1/3. We can look at it as multiplying both sides by 1/3, or divide both sides by 3, however you want to look at it. If I multiply both sides by reciprocal of 3, which is 1/3 here. I would have 1/3 times 3y on the left hand side, and the right hand side I get 1/3 times 6 minus 2x. And as you see, 1/3 times 3 over 1 would be equal to 1. So 1 times y would be equal to y. I isolated the y here. So we have y is equal to 1/3 times 6 minus 2x, or I can distribute 1/3 times 6 would be 6/3, minus 1/3 times 2 would be 2/3 x. So y is equal to 2 minus 2/3 x. What is the ratio of 10 feet to 4 yards? Well, we need to convert the unit here. We know 3 feet is equal to 1 yard. So if I convert 4 yard we have 4 yards here. Let's convert that to feet. To do that, we have to write a fraction. At the bottom of the fraction, we have to put the yard, and the top of the fraction, we want to write here feet. And look at our conversion. That 1 yard is equal to 3 feet. So in this case, the yards would cancel, turns to 1. So we have 4 times 3, which is equal to 12 feet. So that means 4 yards is equal to 12 feet. And to write the ratio, we have 10 feet over, instead of writing 4 yards, now we're going to write 12 feet to have the same unit. So we have 10 over 12. We reduce that to 5/6. Solve for x. To solve for x, we have to eliminate 7x to isolate the x here. To do that, we multiply both sides of the equation by reciprocal of this coefficient, which is 7 over 8. The reciprocal of 7 over 8 is 8 over 7. If I multiply both sides of the equation by 8 over 7, I would have 8 over 7 times 7 over 8 is equal to 1. 1 times x would be x. So x is equal to 8 over 7 times 2. 2 times 8 is 16 over 7. Solve for x. We have 4x plus 9 is equal to 7. To isolate x, we need to eliminate plus 9 here. So if I subtract 9 from both sides of the equation, I will get 4x on the left-hand side, and the right-hand side I will get 7 minus 9. So 4x would be equal to minus 2. Now to isolate x, I need to multiply both sides by reciprocal of 4, which is 1 over 4, or divide both sides by 4. So if I multiply both sides by reciprocal of 4, I will get 1/4 times 4x. I can put the 1 here. I have 1/4 times negative 2 over 1. So 1 over 4 times 4 would be equal to 1. So 1 times x is x. X is equal to minus 2 over 4, which is equal to minus 1/2. Reduce that to negative 1/2. Solve for x. We can distribute here. We have x plus 2 times x would be 2x. 2 times minus 5 would be minus 10, equal to 15. Combine like terms of x plus 2x would be equal to 3x, minus 10 is equal to 15. We add 10 to both sides of the equation to isolate x. So I would get 3x is equal to 15 plus 10. So we have 3x is equal to 25. And at this point, we can multiply both sides by reciprocal of 3, which is 1/3. Or you can look at it as dividing both sides by 3. Multiply 1/3 to both sides of the equation. I would get 1/3 times 3 is equal to 1. 1 times x is x. So x is equal to 25 over 3. And it's already reduced. So that's our answer. Solve. Here we have an equation involving fractions. If you look at the 4, and here we can put 1 here, denominator is 1, we have 4 here, and the denominator is 2, and here is 3. If you find the LCD of 2, 3, and 4, the LCD between 2, 3, and 4 would be, using 2 and 4 would be 4, between 4 and 3 would be 12. So it's 12. When you have an equation involving fraction, we can multiply each term by LCD to eliminate all the fractions. Let's do that. We have 12 over 1 times the first fraction, which is x over 4, plus 12 over 1 times 2 over 1 equal to 12 over 1 times x over 2 plus 12 over 1, or just 12 times last term 1/3. So we have 12 divided by 4, give me 3. So I have 3x. I eliminate the fraction here. Second term, we have 12 times 2. That becomes 24. On the right-hand side, I have 12 divided by 2, which is 6. We have 6x plus 12 over 3, which is equal to 4. So by multiplying each term by LCD, we would have a linear equation with no fractions, and we can solve for x. So in this case, if I subtract 3x from both sides of the equation, I would get 24 is equal to 6x minus 3x plus 4. And if I subtract 4 from both sides of the equation, I would get 24 minus 4 on the left hand side, and the right hand side I get 6x minus 3x. So I would have 20 is equal to 6x minus 3x, which is equal to 3x. To solve for x, I multiply both of the equation by reciprocal of 3, which is 1/3. If I multiply both of the equation by 1/3, I would get 1/3 times 20 is equal to 1/3 times 3x. So on the left hand side I get 20 over 3, and on the right hand side 1/3 times 3 is equal to 1. 1 times x would be equal to x. So isolate x that way. So x is equal to 20 over 3. Solve for x. In this equation we have decimal. To eliminate decimal, we can multiply each term by a factor of 10. And since we have the coefficient of x here is in the 10th digit here, and so as the second and the last term, if I multiply each term by 10, I would eliminate all those decimals. So I have 10 times 0.4x plus 10 times 0.4 times 10 minus x. And here we have 10 times 0.5 times 10. We have 10 times 0.4. Here we have 4, so it would be 4x plus 10 times 0.4. That would give you 4 times 10 minus x, which is equal to, in this case, 10 times 0.5, which is equal to 5 times 10. As you see, by doing this, we would eliminate all the decimals here. So we have 4x plus, here we have 4 times 10 is 40 minus 4x is equal to 5 times 10 is 50. So far we have 4x plus 40 minus 4x is equal to 50. So if I subtract 40, we have 4x minus 4x is equal to 50 minus 40. Then we have 0x, or 0, is equal to 10. So in this case, it means no solution. And we have all the zero drops to a number like that, that would be no real solution. Solve for z. In this case, we have a proportion, and we have a over b is equal to c over d. We can cross multiply these. A times d is equal to c times b. So in this case, we have z times 100 would be 100z is equal to 20 times 80. So we have 100z is equal to 1600. To solve for z, we can multiply both sides of the equation by reciprocal of 100, which is 1 over 100. Or you can look at it as dividing both sides by 100. And that would give me 100 times 100 would be 1. 1 times z is equal to 1600 over 100, which is equal to 16. Solve for x. In this case, we have a fraction. The LCD of 5 and 6 is equal to 30. If I multiply each term by 30, or 30 over 1, I would eliminate all the fractions here. So on the left-hand side, I have 30 over 5, which is equal to 6 times 3 plus 4x is equal to 30 over 6, which is equal to 5 times 2 minus x. So by multiplying each term by LCD, I would eliminate all the fractions. Then I can solve the linear equation here by distributing. 6 times 3 would be 18 plus 6 times 4x would be 24x is equal to, and I distribute here, I would get 5 times 2, which is equal to 10 minus 5x, and I can add 5x to both sides of the equation. I would get 24x plus 5x plus 18 on the left-hand side, and the right-hand side I would get 10. Then I subtract 18 from both sides of the equation. I would get 24x plus 5x is equal to 10 minus 18. So I would have 29x is equal to minus 8. I multiply both of the equation by reciprocal of 29, or divide both sides by 29. X would be equal to minus 8 over 29. Find the average of the following fractions. To find the average, we need to add all these numbers together and then divide it by 3, because we have 3 terms here. Since we have a mixed number, the best way to add this would be to line them up and add all the mixed number together first, and then add all the whole number together. You can put 0 here as a reminder that is no whole number for the second one. We need to find the LCD between 5, 10, and 15. The LCD is 30. So we need to multiply 5 by a number to have 30. So it would be 6. So multiply the first fraction by 6 over 6. And for the second one, we need to multiply 10 by 3. So we'll multiply this by 3 over 3. And finally, multiply 15 by 2. So we would get these numbers to be 3 and 12 over 30. And here the whole number is 0, would be 27 over 30. And here we have 22 over 30. So we add them up to be equal to 12 plus 27 plus 22 would be 61 over 30. And we add the whole number together, we would have 3 plus 2 would be equal to 5. So we have 561 over 30. We need to divide this into 3. This is a sum. And to do that, we can change this to the improper fraction by multiplying 5 times 30 plus 61. So 5 times 30 plus 61 over 30. That would be 211 over 30. So this is a number we need to divide into 3 to find the average. 211 over 30 divided by 3, or 3 over 1, is the same as 211 over 30 times 1/3. You change the division to multiplication, and we write the reciprocal of 3, which is 1/3, and that would give me 211 over 90, which I can write it as a mixed number by dividing 90 into 211. Give me 2, and the remainder here would be 31. So the average would be the average of those 3 numbers would be 2 as a whole number, and 31 over 90. Solve and graph the inequality. Solving inequality is very similar to solving equation. We need to isolate x, so I can subtract 3 from both sides of the inequality. So we get 2x less than or equal to 11 minus 3, which is 8. And divide both sides by 2, I would get x less than or equal to 4. If you divide by or multiply by a negative number, then you have to change the direction of the inequality to its opposite direction. In this case, we didn't. We just divide both sides by positive 2. So the direction of inequality stays the same. To graph this, we locate 4. X is less than or equal to 4 would be all the numbers that are less than 4. So all the numbers that are less than 4 would be to the left of 4. So that would be the graph of the inequality. Solve and graph the inequality. Here we have to isolate x, so we add 4 to each side of the inequality. So we would have negative 4 plus 4, that would be 3. And we have 3x here. And 8 plus 4 would be 12. We divide this term by 3. We can isolate the x, so x would be in between 1 and 4. To graph this, we locate 1 and 4. And we're going to include 4 because it says equal to, but we're not going to include 1. Use a hole here, and all the numbers in between would be included. So all the number between 4 and 1, including 4, excluding 1, would be the solution. The complement of an angle is 1/3 of its supplement. Find the measure of an angle. Well, let n be the angle that we're looking for. The complement of the angle then would be 90 minus n. So complement means when you have two angles add up to equal to 90 degrees. So if one of them is n, the other one must be 90 minus n. This would be in case of complement. For supplement, if two angles add up to 180 degrees, if one is n, the other one must be 180 minus n. So in this case, we have the complement of an angle. So complement of an angle would be 90 minus n means equal to 1/3 of, so it goes 1/3 of its supplement. Well, supplement is 180 minus n. So this is how you set up the equation. Again, the complement of an angle is 1/3 of its supplement. So if two angles are supplement of each other, one is n, the other one is 180 minus n. If two angles are complement of each other, if one is n, the other one is 90 minus n. So we solve this equation for n, and here we can distribute this 1/3. We have 90 minus n is equal to 1/3 times 180 would be 60 minus 1/3 n. So we have 90 minus 60 is equal to, here we have minus 1/3 n. If I add n to both sides of the equation, that becomes plus n. So 90 minus 60 would be 30 equal to, we have minus 1/3 n plus 1 n. Instead of 1 n, I can put 3/3n, so I can combine these two. So in this case, I would get 30 is equal to minus 1/3 n plus 3/3n. That would be minus 1 plus 3 minus 1 plus 3/3n. That's what we have. So we have 30 is equal to 2/3 n. To solve for n, we multiply both sides by 3/2. So we have 3/2 times 30. We can reduce this. That would be 90/2. That's our angle n. So 90/2 is the same as 45 degrees. So the measure of the angle is 45. When the smaller of two consecutive integers is added to 4 times the larger, the result is 54. Find the integers. When we talk about the consecutive integers, like if you have 1, 2, 3, 4, and so on, if the first number is n, the second number would be one more than that, so it would be n plus 1. The next number would be one more than that, would be n plus 2, and so on. So when the smaller of two consecutive integer, what we can do here is say let n be an in this case, let's n be the a smaller integer, then the next integer would be n plus 1, is the next consecutive integer or larger integer. So assuming the first integer is n, which is a smaller one, The second one after that would be one more than that, which is n plus 1. Now we can write our equation based on the scenario we have here. When the smaller of two consecutive integer, which is n, is added plus to 4 times the larger one. 4 times the larger one. The larger one would be n plus 1. So the next integer is the larger integer. So if you're assuming this smaller integer is n, the next integer is n plus times. The larger one would be n plus 4 times n plus 1. It's supposed to be adding to 54. So this is the equation you have to solve for n. We distribute, we get n plus 4n plus 4 is equal to 54. Here we have 5n plus 4 is equal to 54. So we subtract both sides by 4. I get 5n is equal to 50. So n is equal to 50 over 5, which is equal to 10. So the first integer is 10. The next one must be 11 then. The two integers that they're referring to would be 10 and 11. If the quotient negative 36 and 9, so we write it as negative 36 over 9, is subtracted from the product of 2 times 11. So whatever comes afterward from should be written first. So this would be the quotient of negative 36 and 9, and 2 times 11 would be the product of 2 and 11. So it says to subtract the quotient of negative 36 and 9 from the product of 2 times 11. So we have to write 2 times 11 first, minus the quotient of negative 36 over 9. So that would be the equation. Subtracting negative 36 over 9 from the product of 2 times 11. So this would be 22 plus, that would be 36 over 9. So 22 plus 4 should be 26.